All right, this is where it gets a lot of fun. I see we've got only 83 people. I feel sorry for those folks who didn't make it this morning. Um, Principles of Product Development Flow. It's the Reinertsen book. Donald Reinertsen. It's the second generation lean product development. How do we produce? How do we do products in the world of agile? Basically, um, it's a very interesting book. One of my favorites. I think, at least in my practice, even on a daily basis, when I run into product managers, product owners, managers, scrum masters, people who are looking at creating products, especially software products, but it could be any products. I think this is a must read. I think this is almost like the Bible for agile software development and agile product development. Um, Reinertsen has 7 topics. We're going to go through each of those topics at a high level. I still recommend reading the book as opposed to just listening to these lectures. It will be basically today and part of Thursday. More than likely, I won't get through the whole thing today. Maybe we'll see. Reinertsen didn't set out to create a book on Agile, but I believe he has written one of the best books on Agile. Why we should adopt it, how we can adopt it in some respects, but certainly why we should adopt it. And then a lot of the things that he has in here, if anybody, I don't know how many people have actually cracked this book open, bought it, and tried to read it. Um, he has got a lot of math and charts, and there's a difference. Is I always say to classes, and I had this discussion with my son the other day. I don't know if I mentioned it to you all before, but there's a difference between math and science, and there's a difference between math and obviously humanities and other things because he was struggling with his English paper. Um, and I told him, I said, the reason that you don't struggle sometimes with math is that there's almost always one right answer, and it can be proven. So as long as you logically follow mathematics, you can actually get to a correct answer. It's not the same when you write an English paper, right? It's not even the same with science because science, by its very nature, is falsifiable. If it's not falsifiable, then it's no longer science. It's a dogma. You stepped almost into the bounds of religion here. Um, so these are things that can be proven. The whole book is this isn't Larry's opinion. This isn't Don Reinertsen's opinion. Now, if you have a problem with the logic of the mathematics and he's done something wrong in the mathematics, that's a different story. I don't think he has. He was if I remember correctly, a nuclear sub engineer. He's a very bright guy. Um, anyway, I don't have a lot of regrets in life, which is good. I think that's a good way to go about things. I do have one regret with this particular book is that I did not read it sooner. And it wasn't because I didn't have opportunities to read it sooner. It was because people were always coming to me and saying, Larry, you have to read this book. This is a really good book. The problem was uh, the cover. I had a problem with the cover. Anybody know why I had a problem with the cover? So those folks who've taken the class before know. You see what he's got on the cover? What is that?
Waterfall.
Waterfall.
Waterfall. So everybody recommend this book, and they said, Larry, you got to read this book. And then I look at the book. I go to the bookstore on Amazon or whatever because I got my Kindle. I love my Kindle. My wife told me the Kindle is dead. I didn't know that, but mine isn't. But Principles of Product Development Flow. I'd go to Amazon. I'd look to buy it, and I'd look and I'd see this picture on the front cover, which is a waterfall, and I'd say, why the heck are these people telling me to read a waterfall? Right. And so I resisted for quite some time. I wish I wouldn't have. It's not a waterfall book. Unfortunately, again, he's not thinking about agile, waterfall, et cetera. He's just, thinking about the term flow. How do we get things to flow through the system? And what better idea of flow than water? But unfortunately, he put a waterfall and then, unfortunately for me, I mean, not for him, but unfortunately for me, he put a waterfall on there and I didn't read the book for quite some time. When I did, it blew me away. And I'm probably due. It's been some time since I've read it. I probably need to reread it. But it's not an easy read. For those of you who have cracked it open, tried to read, it's not easy. Even Reinertsen himself admits that it's very difficult read. He uses a skiing analogy, which I'm not too familiar with because I've never been skiing, but I know the thing. He says this book is the double diamond course of his books. He's got some other books. It's the toughest one to read. Why do we read it here instead of the easier ones? Because it may be the toughest one, but it's also the most important one. So I'm going to go through again over the next day or so the 7 topics, and I'm going to present some information as I see it. Again, I encourage you to read the book because the book is better. This is like the movie. The book is always better than the movie. The movie could be good, but the book is better. So, first topic in Reinertsen's book, we need to understand economics. If we're creating products, we need to understand the economics. Why? Well, for those of you, we'll talk a little bit about it before. The goal of a for-profit company is to actually make a profit, and there's not necessarily anything wrong with that. Whether your company does good or evil, the only way it's going to continue to do good or evil is by making money and making a profit, so it can continue to exist. So when we're looking at a product, and again, I'm going to look at a software product, but you can imagine any other product that we're developing or creating or enhancing. When we look at it, and software is really good because software can be relatively easily enhanced compared to other products. All product, this is a quote, product attributes should be quantified using a standardized and useful unit of measure. And what is that unit of measure that we should use so that we can take everything that we might want to put into that product and decide what the right things to do are. And that thing that he talks about is life cycle profit impact. If I am to do this thing, how will it affect my life cycle profit, right? Not just how will it affect today or tomorrow. All right, but how will it affect it throughout the entire life cycle? Will this, will this thing bring in $1 million? Will this thing, save us $1 million? What is it going to do? And how can we measure that? And every decision that we make in product development should be made with this understanding. I don't think it's any different from lean. Lean just says remove the waste, and then everything that's left will be things that actually contribute to your bottom line. All he's saying is the other way around. Identify those things that will contribute most to the bottom line. And if you've gone through the book, he says perhaps the most important thing that you should consider, not the only thing, but the most important thing when you're considering life cycle profit impact is something called cost of delay. And cost of delay is a concept that's relatively easy, but if you're not familiar with it, I've got a nice video that will explain it. And we'll show that, I think, in the next slide. So I'm going to let the good people at Black Swan Farming in their video explain the concept of cost of delay. The interesting thing about this concept of cost of delay is that Reinertsen, and he's an active consultant, and I can't remember what the consulting group is. Somebody will probably look it up and throw it in the chat for us. 85% of companies do not in any way compute cost of delay. So if you haven't heard the term cost of delay before, no big deal, because most companies aren't even using cost of delay when it comes to creating their products. The key to this whole thing, I had nowhere else to put it, but the last bullet point is we have to stop concentrating in product development in the complex world, in the knowledge-based world, on the worker, the person doing the work. The worker is the input, is part of the input into the product. That's not important as the product itself. So if we want to concentrate on anything, we should concentrate on the product being built and not the people building it. Because if you're doing something in the simple or even sometimes in the complicated world, I always use digging ditches, but digging ditches, yes, the input is proportional to the output. So if you can keep somebody working and working efficiently, then the quote unquote product is going to follow suit. but that doesn't work in the complex world. We have to concentrate on the product. So what we should be watching is the system. We should be watching the system that creates the product, and as opposed to the people doing the work. This was an analogy I used before. We shouldn't be that concerned whether a salesman puts in 60 hours a week or 20 hours a week. If they sell the same amount of stuff, right, and they're not cutting corners, what difference does it make? Right? So we need to be outcome focused. We need to be output focused, not input focused. And that's a tough thing because that's not what we're taught in most business schools, as far as I'm concerned. And that's what I've been told. I haven't taken my MBA yet, but I've been told by people who teach it that they teach. I think I told you before, there's a professor at Berkeley, Haas School of Business. I had a conversation with him. He said, we teach people how to run 1860s railroads very well. Right? But that's not what we're doing anymore. We're not running 1860s railroads. I call this the G-GOAT, the greatest graphic of all time. That's a joke. I am not very good with graphics, but this graphic explains in certain things. I'm going to refer to this again and again. People in the past have threatened to try to improve the G-GOAT, but they have not yet. I'm still waiting, but I'm sure it will happen. You have an idea. Just like we talked about before, right? We have an idea, you put on a backlog. Most companies, you have an idea, and it goes through a series of steps where things are done to that idea until we can make money. This is what counts. This is the output. Everything from the original idea to here, all this doesn't necessarily matter. I mean, it matters in the sense that we're creating money at the end. But what matters to us as a company is actually getting to the money. It's not getting to step 3. There is no value in step 3. We are not delivering anything in step 3. It's only when we get to the far right. I don't know. Can you see my cursor if I do this? Okay, I didn't know.
You can see your cursor. You can also use the annotate on Zoom to get the laser pointer to show.
Okay, all right. Well, I'll stick with this one. So over here on the right, it's the only thing we care about. All of this, if you want to think about it, and here's when we talk about lenses, here's a lens that's a very powerful lens. All of this is inventory, right? If you're running a store, let's say you're running a bodega on the corner, is there value to the stuff on your shelves? To you? No. In accounting, we call that a liability. There is no value to you as a shop owner to have things on the shelves. In fact, in a perfect environment, not that there is one, you would have nothing on your shelves. As soon as it hits your shelves, it will be sold because on your shelf, it is inventory. When we're creating products, we don't have inventory in the classic physical sense, but we have inventory in the sense that you have an idea here, and that idea is, let's say it's worth $1 million. Once I put that on a backlog, it becomes inventory. Your inventory is a backlog of ideas. In itself, it has no value, just like physical inventory. It only has value when that is sold, when it is delivered and sold, okay? Just like physical inventory. So that's a good, when we talk about mental models and lenses, that's a good mental model, is to borrow the concept that ideas are worth money. And when you put them on your backlog, what you're doing is you're taking inventory. But inventory in and of itself is not worth, it's not worth it to you as a company. It is a liability to you as a company. So the idea of backlog management, which we talked about on day 2, is to identify those things that are the most valuable inventory in terms of profit and getting those things out as quickly as possible. Everything else doesn't matter. We get so enamored with process and other things. It doesn't matter, right? And if you look at, I started on day 1, I told you, and by the time we get done with Reinertsen and some of the mental models and lenses that we're going to present, when I say that I believe I could double the net profit of any software development company in the world, were they to give me complete and utter authority, which they never will, you're going to see why I believe that to be true. Because we have so much locked into inventory. I tell a lot of times I'll talk to my product owners and product managers at a company and I'll say, look, if we treated our physical inventory the way we treat our mental inventory, we wouldn't have a job tomorrow. Not just you. None of us would. Because we wouldn't just put a bunch of inventory on the shelf and hope that it sells. Right? Because we'd have a physical manifestation of it. This is why it's so important that we take everything that we're going to do and make sure that it is on a backlog and that it's sequenced correctly. Because that is inventory and it's a liability. It's worth nothing as inventory. You with me? I'm beating the horse. It's dead. I'll beat it some more. It's really important to understand this concept because it's not the way we think. So that's the life cycle, and I'll show you. It's very similar to companies I go to where they have 7, 8 steps before they can get a product out and actually make money on it. And each of those steps, if we're doing waterfall, what we do in waterfall is we take a bunch of ideas and we put them all together and we put a bow around it. We call it a project, which is really just an accounting code. Let's keep all this stuff together and track it together as one accounting code. We'll fund it with one accounting code, and we'll try to keep track of whether or not we make money with one accounting code. That's why waterfall is a big batch process. I'm going to take that whole batch and we're going to move it through these queues. And each queue has an input queue, a server queue, and an output queue. Meaning it's got work waiting for somebody to work on in this station. And then we're working on it in this station. And then sometimes it sits in an output queue until somebody picks it up and brings it into their input queue. And not only do we do that with ideas, but we do multiple projects at one time and we try to throw them all through the same system. It's not a very good way that things normally work. So I'm going to refer to this quite frequently. I've got to do something real quick, because I got to share the sound and hopefully this will work for us. Okay, so Black Swan Farming put a video together some time back about cost of delay. And they do a good job or better than I could probably do of explaining it. So I'm going to let them do it in a second. But if you want to go for a kind of dictionary definition of cost delay, cost delay is a way of measuring the impact of time against expected outcomes, a way of communicating the impact of time on the value, right? So basically it's saying, keeping all this stuff in inventory, how does this affect our bottom line? If we think about ideas as inventory, how does keeping ideas in the pipeline affect our bottom line? That's another way of looking at it. But I like the video, so let me see if I can get this thing working. Hang on one second.
In most organizations, it seems to take a long time to get things done. Part of the reason for this is not that each of the actions required takes a long time, it's that things actually spend most of the time in various queues waiting to be worked on. Here's a fairly typical example. It's a feature that took a total of 46 weeks to deliver from when it was first captured. Of that time, it actually spent 38 weeks waiting in various backlogs and queues. You may not believe it, but if you do the same thing in your organization, you'll probably find something similar. It is not unusual for the amount of waiting time to be in excess of 80% of the total time taken. Seems crazy, doesn't it? The thing is, most organizations are blind to queues. We tend to focus more on the efficiency of the parts of the process, not the whole system that is required to deliver value. This hides how long it takes to deliver value end to end. Part of what drives this blindness is that we have a really poor understanding of how much the delay is costing us. Our gut feel about the urgency and value of things is often quite wrong. For instance, when we worked out the cost of delay for this feature, we discovered that it was actually worth over $200,000 per week. So, the 38 weeks that this opportunity spent waiting in various queues actually cost the organization almost $8 million in revenue. If they had known the cost of delay earlier, they would have done a number of things differently. If we are to make better decisions, we need to understand how the value of the things we are working on is leaking away over time. Knowing the cost of delay means we can put a price tag on all these queues and waiting. So, understanding the cost of delay helps us in 3 ways. Firstly, It helps us make better decisions by making the economic trade-offs visible. The value of speed over efficiency is easy to understand. Secondly, it helps us with prioritization. By using CD3, cost of delay divided by duration, we actually deliver more total value for a given capacity. And lastly, cost of delay helps us to change the focus from dates and cost estimates, which can encourage the wrong behavior, to speed and value. Put simply, cost of delay is a way of communicating value and urgency. Without information about the cost of delay, the system will optimize for other things.
So makes a lot of sense, right? Cost of delay. We got to figure out, is holding this stuff in inventory, what is it really costing us? How do we deal with cost of delay in Agile? How do we deal with this lifecycle profit impact? And what you're going to notice is you're going to notice the things that we learned early on in day 2. I'm going to keep going back again and again to these very simple concepts, because we need to have simple ways of attacking the complex world, right? 1, sequence. Cost of delay is mitigated by taking advantage of intelligently sequencing our backlog, by taking the items that are in our backlog, our intellectual inventory, if you will, and making sure that all of these things have value and effort so that we can sequence properly to deliver the most value over the shortest amount of time. If you remember from the video you just saw, they referred to something called CD3, which is the mathematical way to reduce your cost of delay. CD3 is cost of delay over duration. What did we do? Well, we talked about value and we talked about effort. And if you want to go back to, in your memory banks, day 2, when we talked about sequencing the backlog, and we did 2 relative estimation exercises. We did, what was the relative effort of the work? And the relative effort is a proxy for duration, okay? In that CD3 equation, cost of delay over duration. The value, if you remember from day 2, I asked a very simple question. If I delivered this thing today versus this thing today, and the reason I say that in that particular way is that I'm basically asking a cost delay type question. So value becomes a proxy for cost of delay. So value over effort is a proxy, an estimation for CD3. And using the relative techniques that we learned in day 2, I can get to CD3, or at least something akin to CD3, very quickly, because I can take a backlog of 100 items and I can put effort on every single one in an hour, and I can put value on every single one in an hour. And then 2 hours later, I have a properly, or at least a well-sequenced backlog. This type of sequencing, I don't know if I mentioned it before, is called WSJF, or weighted shortest job first, as opposed to other sequencing methods. If you're doing manufacturing, you usually do something called FIFO, first in, first out, because it doesn't matter in manufacturing when you create something, because everything should be exactly the same in terms of value and effort. That's the difference between running the 1860s railroad and running manufacturing facilities and running a knowledge work company. You have to understand the value and the effort, because they're not going to be the same. They are going to be different. Topic number 2, we're going to manage our queues. In Black Swan Farming, they talked about managing queues being an important part of what we do. Queues and queuing theory are nothing new. It is credited to Agner Erlang in 1909. The only reason I mentioned that is some of you who are really geeky and into programming might recognize the name Erlang, which is a programming language named after. According to Reinertsen, and I believe what he has to say, queues are the root cause of the majority of economic waste in product development. Basically, we don't understand queues, we don't take advantage of queuing, we don't do weighted shortest job first, etc. Queues and knowledge work, which is what product development generally is, it's ideas. right? Knowledge work. They're problematic because they can be invisible or largely invisible, right? If you look at manufacturing, when we look at theory constraints, which we'll look at a little later, maybe on Thursday, if not next week. Theory constraints, if I have a constraint in the physical manufacturing system, I'm going to see it because goods will actually start to pile up somewhere, right? I will see a physical manifestation of problems. In knowledge work, because ideas don't have a physical manifestation, we actually have to give them a physical manifestation. And the way we do that is we identify the idea and we put it in a backlog. Now it has a physical manifestation, the physical manifestation being the item in the backlog, because now we have visibility into the queue. Without actually doing proper backlog management, it becomes invisible. It's almost as I've got a bunch of inventory stuck somewhere and I don't know where it is. I can't find it, and therefore I can't move it or sell it. Queues are the biggest reason for a high cost of delay. Also, they're a big reason for not, especially when they're improperly sequenced, not taking advantage of actually delivering the highest value in the shortest time. Queuing theory is really basically pretty simple. There's only 3 elements in a queue. There is the queue itself. There are customers and there are servers. In this example that you have here, this is a perfect example of a queue. It is a queue of cars. In this case, the customers are the cars, and the servers in this case are the number of lanes, right? So if we increase the number of lanes, the queue will get smaller because more of the customers will be able to get through the system. If I decrease the queue, the number of servers, then the queue will increase in size. But the delay that it takes, anybody knows, that's why traffic's a great example. You've all been stuck in rush hour traffic before. Reducing traffic by 1 lane does not have a proportional effect to you. If you have 5 lanes of traffic and you reduce it down to 4, it should take you mathematically 20% more to get where you're going, but it doesn't. It's a nonlinear relationship. One of the reasons people who understand queuing theory, that's why we do metered on-ramps. We're trying to slow the flow of traffic into the queue so that we don't overcapacitize the queue. Once you overcapacitize the queue, you'll see this hockey stick effect in terms of wait times. Anybody who's been in rush hour traffic can relate to that, right? Losing 1 lane of traffic doesn't take you 20% more. It could take you twice as long to get where you're going. I think Disney, I don't know how many people have been to Disney and done the fast pass thing, right? Anybody? Nobody taken their family to Disney lately? I used to take the family to Disney. I think it was 3 or 4 years in a row when the kids were little. And we have a big family. I think one time I took like 16 people because they took kids and friends and everybody. I had to I put a second mortgage on the house in order to go. They use fast passes. And what a fast pass is it's queuing theory in practice. What you do is you go up to the popular rides and there's a little machine and you press a button and it hands you a ticket. And it says, instead of you waiting in line, come back in 45 minutes. That's how long you would have waited in line. But we don't want you waiting in line because when you're waiting in line, you can't be spending all your hard-earned dollars on mouse ears and $20 hamburgers, right? I don't know if they're $20 hamburgers, but I can imagine. You can't spend money when you're sitting in line. I don't want you sitting in line. You don't like it. I don't like it. I'm going to give you a ticket, say come back in 45 minutes. You go right up to the head of the line. You don't have to wait. During that time, you're going to spend some more money, right? So what are queues? In the G-Goat greatest graphic of all time, you can see the queues. At each station, as we're moving the work through the system, there's an input queue and there's an output queue. We need to pay attention to them, right? Because we have this interesting assumption as human beings, and they're not always right. In fact, I think it was one time, I've used this advice before. If I had, an elevator ride with the CEO, somebody told me if you only have like a minute to get their attention and tell them something that you think is important for them to understand. I would say that the most important thing for the people who have power in an organization, especially in a complex organization, to understand is do not trust your intuition. Human intuition is built for the complicated and simple world. It's not built for the complex world. So the things that happen in the complex world are different than the complicated and the simple world. Your intuition will generally lead you astray. Because we tend to think that higher utilization of people and resources, even physical resources, will lead to faster product development. This is not true, right? I mean, a traffic jam is high utilization of resources. We're throwing as many cars possible as we can at the problem, but that doesn't solve the problem. Because what happens is when we overload queues, the cycle time, the ability to move through the system, increases in a nonlinear fashion. We all know this. And it looks something like the picture on the right, which is capacity, queue length. What is the capacity of the system and how do things move through the system? As we increase the utilization of the system, which is the bottom, the horizontal axis, our wait time increases non-linearly. Almost every system has this type of footprint, and it's just a matter of at what percentage do we start to see this huge increase in wait state. This looks very much like a CPU. If you're familiar with computers, this could be a CPU utilization curve. It's amazing we treat our computers better than we even treat our people, honestly. But this, again, a complicated world versus the complex world. As we increase utilization of a CPU, the instructions that the CPU has to handle get stuck in a queue. And what happens to your computer? It slows down. Once you hit a certain point of CPU utilization, it doesn't just slow down, it almost comes to a stop, right? And that's generally, we start to see that inflection point, generally 70, 80%. So what do? You get more CPUs. What do we do with people? No, we just pile more work on them and wonder why things don't move through the system. The same thing happens with anything, right? Because if you're doing knowledge work, your people are your servers, and queuing theory tells you if you overcapacitize your servers, what's going to happen to your wait state? It's going to go way up. What's going to happen to cost of delay? It's going to go way up. What's going to happen to inventory? You're going to have a lot of it. It's going to be backed up. You're going to have a traffic jam of ideas, if you want to use that metaphor, right? So this is really important to understand. And this utilization queue is in something where things are rather uniform. What happens in the real world when we're in the complex world, this is like manufacturing. If you talk to any GM of a manufacturing plant, they will tell you what their optimum utilization rate is. It's not 100%. Because they know that if they try to utilize it 100%, they're going to see goods piling up all over the warehouse or all over the manufacturing facility. They'll be able to tell you what the optimal utilization rate is, right? That's in a physical environment. What happens if you're in a complex environment where there's variability between the value and the effort that it takes to move items through, where items are not uniform in size? Well, guess what? When there's variability in the queues themselves, and this is mathematical, again, this isn't Larry's opinion or Don Reinertsen's opinion, this is mathematical. When there is variability in the input, like there is in a complex world, the curve shifts to the left. What does that mean? That means that we hit that inflection point at a lower utilization rate. This is pretty interesting, right? What should we do to move more things through the system? Well, what most people do is we try to push it through, right? This is management 101. We're not getting things through the system. Let's just push it through. Let's just put pressure on the system. Let's put pressure on the people so we can get things through the system. It does not work because it cannot work. Okay, it's not that, you can work longer hours and everything like that, but that's a different, you're not overcapacitizing the system, right? Because you're just basically adding more capacity to the system by overworking people, which doesn't work, by the way, because of quality issues. But regardless, You have to understand, if you want more things to move through the system, you need to take things out of the system. So if you want more traffic, if you want traffic to flow faster, what do? You either add more servers, queuing theory, or you have to take traffic off of the system. There's no other way around it, right? So there's a wonderful video with Steve Jobs when he came back Apple second time. And obviously, they did a better job the second time around, though they were on the brink of bankruptcy, and it was Microsoft that basically saved them, which was a shame, because Steve Jobs was always kind of a jerk to Bill Gates, and Bill Gates saved Apple. So if you're happy with your Apple products, think of Bill Gates as much as you think of Steve Jobs. Regardless, he comes back. He's been around the block now. He's learned a few things. And the very first thing he does, and this was the launch of the new iMac with the colors, which is always interesting, because now what is Apple advertising? Colors. That to me is always, when I run out of ideas, I'm going to just make the same things in different colors. That's my interpretation of it. But they're paying these people a lot of money to come up with an idea. Let's put things in 5 colors. I could do that. Pay me the money, right? When you run out of ideas, I'll just call me, send me a check. Anyway, he's talking about the launch of the iMac, but he's talking about how are we going to save this company as well. And in fact, in the video, he's in shorts and flip flops, I think. And I don't know if you can find that video anymore on YouTube, by the way. But one of the things he says that most people don't pay attention to, because he's talking about the Think Different campaign, right, where they had Einstein and all this stuff. You all remember those commercials, right? He says, here's what I did very first thing when I walked in the door. I said, show me all the projects that you have in flight now, all the stuff that you're working on right now. And he cut 60% from it, like that day. Because he knew that when you overcapacitize a system, you're not going to get things through the system. We have to take cars off the road if we want the cars to get where they're going faster. And that's what he understood. And that was pretty smart of him. But it's interesting that that is overlooked for the other stuff. But that's the way we are as human beings. We tend to notice the bright, shiny objects and not the other things. We tend to reward the people who put out the fires, not the people who keep the fires from starting in the first place. I only mention that because that's part of my job. Actually, it's my team's job. My job is to help the teams that do that. It's not just the items that we have in a single queue that is a problem. It's further compounded by most organizations who are not optimal, because what they do is they make each of the products, or each of the, the steps along the way to producing the product, they make a lot of different queues. So if I have one queue that's problematic, what happens when I have 2 queues? And now they're both problematic. What happens when I have 3 queues? So it's the number of queues as well. And that's further compacted by the theory of constraints, which tells me that the slowest of the queues is the one that's going to determine the speed with which things basically move through the system. So this is really, really problematic. Again, I want to go back to that very bold statement I said on day one. I can double the net profit of any software development company in the world if I were given unlimited authority. What would I do? I would reduce the size of queues, and I would reduce the number of queues. And we would get our products and the value of the products to our customers much, much quicker, and therefore we would have the opportunity to make more money. There's something called value mapping that's really important. Value mapping is sitting down, and I've done this with organizations in the past. You sit down with somebody and you say, I've got an idea, right? When I have this idea, what steps within the organization must this idea go through in order to get to my customer? And I've done this before. In fact, I've done it where I've taken, a 3x5 card. This is back when we did physical stuff, right? You get a bunch of leaders in a room, and you write down, $1 million on a card. You say, here's $1 million idea. Who gets it first? Walk over and hand it. Write it down on the board. Okay, you've done your work. Where does it go next? Hand it to the next person. Write it down. Put it on the board. And such all the way through. It sounds so simple. It almost is like you're being disrespectful of the people in the room, right? These leaders, but you're not. You're saying you need to see physically the system that you're setting up, because this work has to go through 12 different steps. Do we need 12 steps? Could we do something different? Do we need 12 queues, or can we have fewer? So this is this thing you see here on the screen. This is generally what software development used to be in the waterfall world, give or take. I've got a customer has an idea, boom, clock's ticking, give it to the product owner. Product owner sits on it for a while, whatever, it's in their queue, they got to do some work on it. Finally, they get it there, they get it to an architect. Architect says, oh, we got to do this, make sure it's good for the system. Then they go to a designer. Designer says, okay, here's the design based on the high level architecture. Then they actually give it to a developer, and the developer starts developing it. Then after the developer develops it, it moves to the testing team. Then it gets tested. Testing team says, it's probably pretty good, but let's put it in UAT. Then I got a UAT team, and then finally I release the software to my customer, right? Here's some other problems with queues. Queues and especially long queues, and not having an understanding of queuing theory lead to longer cycle time. So our time to market and cost delay increases. That's the main big problem. But it also increases our risk. Because the thing that I have in inventory, I'll give you an example, a physical example. Just the other day, I had the old house we lived in had a pool, and because of all the storms and things we had recently, the pool started turning green, so I had to shock it, right? So I don't know any pool stores around me, but I know there's an Ace Hardware, and I was in a hurry, so I stopped at the Ace Hardware, and up in they only have one plastic bottle of shock. Chlorine, and it was way up the top. I couldn't find it for a while, but I found it. I had to get somebody to get a ladder and get it, and it was old, and the bottle almost broke as I was pouring the thing. It was just so brittle, it had been sitting on the shelf for so long. There's a risk. In that case, if I had the time, I would have probably gone back to him and said, look, the chlorine, it ended up working, so it was fine, so I didn't do it. But the chlorine you gave me was so old that the bottle broke on the way home. I barely was able to get the chlorine in there, right? You got spoilage. Ideas will spoil, just like products will spoil. If they sit on the shelf too long, you can't sell them anymore, right? So you got this risk that you've got this great idea and it's stuck in a queue because you didn't go to Larry's lecture on queuing theory, right? Or you didn't read Reinertsen's book, and it's stuck in the queue. And by the time you are ready to deliver it to your customer, it doesn't make any difference anymore. Your competition has already beat you to it. The other thing is that you have this variability that when you have a queue that's over capacity, you can get these, this shift in longer cycle times. Right, because if your queues are really over capacity, you get some really strange effects. You've got more overhead. For those of you who are doing projects and things of that nature, you understand this concept of overhead because there's status meetings, right? You have to status the work because it's stuck in a queue. Which queue is it stuck in? How long has it been stuck in that queue? When is it going to come out of the queue? Right? And then you usually have pointy-haired boss yelling at you why this thing's stuck. Basically, what you're doing is you're taking inventory. If you want to think about it like a physical product, I'm taking inventory. That takes time, and it's waste. All status meetings of status of the work are waste, but we need to do that inventory on a longer basis. And the more time that it spends in inventory, the more time we have to spend talking about inventory. Right? There's no value in it. There's lower quality. And this is a big one. Remember we said on day one that the key to the complex world is feedback. Well, queues are delaying feedback. Developers, right? If I'm doing development and I'm putting it into a queue and then I'm waiting for somebody to pick it up from the queue and then they test it, maybe it takes a month, maybe it takes 2 months. I don't get feedback. I don't know. I can't remember what I coded 2 days ago, let alone 2 months ago. And I'm getting defects on it now. Another thing that's really a problem is this increased risk because I don't get feedback from my customer. That's one of the things that we want to be able to do is a lot of times we want to get it to our customer, into our customer's hands and verify whether or not our hypothesis was correct. We have a hypothesis that the customer is going to really enjoy this. Well, how do we know? Well, we need to get it into a customer's hands, right? And if we don't do that, we don't get the feedback. So we have that problem. And then there's this huge motivational sink. How many people, by a show of hands, have worked on a project for a long period of time and never saw that project ever delivered to a customer? That's it. Usually it's everyone. That's terrible, because what we'll talk about later is people are not motivated by money in the knowledge-based world as much as they're motivated by autonomy, mastery, and purpose. And what's your purpose, right? I worked for a year on something, never saw the light of day. That's one of the most demotivating things we can do. So cues are a problem with motivation too, because the people who are doing the work aren't seeing the value being delivered to their customers. So how does Agile and the things that we're learning in the Agile MBA class mitigate this? Well, backlogs are the cue. We start to create backlogs. We start to create a physical manifestation of intellectual work, right? You can call it an idea backlog if you want to, I don't care, or idea inventory. We take these ideas, we put them in inventory, we put them in a backlog. We sequence them so that we can concentrate on the work that needs to be done and the high value work instead of concentrating on all of the work, which is what waterfall kind of forces us to do, right? It forces us to look at everything, right? And when we work on everything, it's a big backlog, it's a big queue. We need to learn to say yes, but. I used to say, learn to say no. This is this very strange thing that I hear in Agile talks from coaches and product owners and things. You got to learn to, if you're a product owner, you got to learn to say no. And I used to say that. I used to parrot that, right? Sometimes we just say things because somebody somewhere that we thought was pretty cool said something, so we say it, right? You ever done that? And don't think about it too much because everybody seems to be saying it. All the cool kids are doing it these days. The problem with that, and we can use any example, right? I got some people who are married, got spouses, significant others, whatever, right? Like me. You probably learned very early on that to get along with your spouse, saying the word no is not a good strategy. You with me? It's the same with our business partners when they have an idea. If you're a product owner and you say no, they're not going to take too kindly to it. It's just human psychology. So they have an idea. It's not a really great idea because you're the product owner and you've got the whole list of ideas. You've got them in your backlog. I don't say no, I'm not going to put it on my backlog. I'm going to say yes, I'll put it on my backlog. But there's 100 items in my backlog. You're now 101. Right? And because I have an understanding of velocity and sequence, it's probably going to be about 10 months before we would even get to it. But I'm guessing that in that intervening 10 months, there's going to be more important work. So the odds of you getting it in the next year are pretty slim. Do you still want me to put it on the backlog? Answer is yes, fine. I'll put it on the backlog, right? You with me on that? Pretty simple concept. Don't tell people no. They don't like it. It's almost like the concept of, what is it, improv? You know, improv with comedy. In improv, you never say no. You never reject somebody's suggestion. You take their suggestion, you accept it, and you build on it. I think that's always a better way of life, right? Your kid comes to you with an idea, and it's they're kids. It's a really crappy idea. You don't say, hey, that's a crappy idea. You say, okay, I get what you're saying, but did you think about this, right? So you kind of accept the premise, but you redirect it. A little bit easier, a little bit better psychology. So when we scale things, there's going to be a lot of talk about scaling. I don't talk too much about it because most of the time we prematurely scale. We should descale as opposed to scaling up. There's a whole bunch of things that are wrong with it. I'll talk about it later. But if we have different levels of the organization, that have different ideas, and they take those ideas and put them into inventory, they've created a backlog. So the way we scale is we have multiple backlogs at multiple levels of the organization, and we use those backlogs and we manage those backlogs and we give value and effort to those backlogs and we sequence those backlogs so that we can focus on the top of the backlog, regardless of where it is in the organization. Right? Because usually you have individuals who are doing the work. We call them developers now. The developers are doing the work in Scrum, right? They have a backlog, whether it's explicit or implicit of tasks, things that they're doing on a regular basis that should correspond in sequence to the sequence of the work that they've accepted into that sprint, which we usually call stories. Those stories are in a story backlog and they have sequence, so that we can concentrate on those stories that are most important to concentrate on and plan those for the sprint. Above stories, we sometimes have another level, epics or features or whatever you want to call it. I don't care what you call it, but that should be in a backlog and it should be managed by someone with value, effort, and sequence so that the teams understand the sequence of the backlog that is above them so they know what work to do. Right? That's how we scale. Anyway, I'll go into more detail later. I'm getting to your question in a second. We also manage queues by creating a sprint backlog. Because a sprint backlog is a smaller subset of work, it's a smaller queue. So now we don't have to concentrate on the entire backlog. We only need to concentrate on a piece of that backlog. And here's the big one. And this is the one that so many places that I've been lately have not necessarily done optimally, is we need to reduce the number of backlogs, the number of queues, or not the number of backlogs, the number of queues. So if we go back to this, notice that we have customer, product owner, architect, designer, developer, tester, UAT, release. Overall, I mean, you can consider the release and the customer external. So you have 6 different queues within your internal system that you have control over. And if you have 6 queues, it's going to take, let's say even if you're doing Scrum, because this is what places are doing. They're taking their existing thing and they're just trying to fold it into Scrum. They're not really changing much. We sometimes call that Wagerfall or Scrummerfall, right? They're doing they're doing waterfall on the front end, they're doing a little agile in the middle, and then they're doing waterfall at the back end. It's not really true agile. The product owner, instead of giving it to an architect queue, which would be a backlog for the architects, and then going to a design queue, we can take the product owner, the architect, the designer, the developer, and the tester, put them all on one team. Now I've taken 5 queues and I've collapsed it into one. What have I done theoretically to the cost of delay? I've cut it down by 80%. Right? You with me? By collapsing the queues into cross-functional teams, I have cut cost of delay by 80% or more. This is why I can double the net profit at any company, because all I have to do is I got to start creating cross-functional teams to reduce cost delay and deliver value to my customers sooner. Topic number 3, exploiting variability. Here's the thing that we want to understand. There's a vast difference between manufacturing and software product development or other product development. And that difference is variability. Variability exists in product development. Oh, now they're going to run the sweeper. Okay, good. This is always fun. The difference between manufacturing and product development and software product development, particularly because that's what I do, is variability. In manufacturing, variability is the wrong thing to have, right? You all get that. And that's what most people are taught in their MBA programs. Let's reduce variability because variability is a terrible thing. In manufacturing, it is. Because I got an iPhone and the iPhone's made up of, I don't know, I thought it was like 1,000 components, less than that, but it's made up of a couple dozen components that are manufactured at a bunch of different places all over the world, and then they take those components and they ship them to a place called Foxconn in China, and then they're assembled. If any one of those components, those 24 components or whatever it is the wrong size, is variable, what happens? I don't have an iPhone because the parts won't fit together. The key to manufacturing and assembly is that I create all the parts exactly the same, and if they vary too much, then I've got a problem. So I'm not saying that variability is something that you want in manufacturing. You want to get rid of it. But the problem is we're not doing manufacturing when we're creating products, and we're not doing manufacturing when we're doing knowledge work, and we're not usually doing manufacturing in the complex world. In the complex world, variability does exist. It is a given state. It is not something that you are going to necessarily change. What we need to figure out in the complex world is how do we exploit variability? What do I mean by variability? When you look at a backlog of things that I'm going to manufacture, every single one of these, the widgets that I manufacture, has the same value and the same effort. It doesn't matter when I do either of those widgets. All that it matters is that each widget is exactly the same, right? So variability is not important, nor is sequence, but we live in a different world. Variability is important in our world, which means that sequence is important in our world. And there's a variability of the items in our queue, right? Some have high value and low effort, some have high value, high effort, etc. And we need to exploit that. We don't want to make things all the same. The other reason is that there's not a single answer in the complex world. There are multiple answers in a complex world, or multiple things we can do in a complex world. One of those is optimal and the rest of them aren't. And they'll have varying degrees of optimability, if that's a word, or efficacy, I suppose. And our job is to try to figure out which one of these things is going to be optimal. If we reduce variability in the world of product development, if we reduce variability in the complex world, what we end up doing is we reduce innovation. Because if you are in the product development world, if you're in the software development world, it is the variability of your product that is valuable to your user. And if you do not have variability, if you are just basically copying your competition, trying to create a version, all you're doing is you're creating a commodity, right? When I buy a piece of gold, I don't know who's manufactured it, who's pulled it out of the ground or anything like that. It has a certain value that's even determined by the market, and I will pay that market price for that gold. It doesn't matter. It is a commodity. If you're in knowledge work and you become a commodity, you're in real trouble, because what happens with commodities is people will try to buy them at the lowest price point possible. The only reason that Apple was able to charge more money for its iPhone than Samsung is for its whatever phone, I don't even know what it is anymore, is because Apple has a perception that theirs is superior quality and that it's different. This is the problem that Samsung has. Samsung has to find a way to increase variability so that people see the Samsung is different from the iPhone and not just something that's trying to follow the iPhone. When you reduce variability, you will reduce innovation. The story about 3M is a very interesting point. You're all probably familiar with 3M as a company because you're familiar with something called Post-it notes, right? 3M actually stands for Minnesota Mining and Manufacturing. It's pretty interesting that they're known for something like Post-it notes, but 3M used to be a very innovative company. They used to, on their balance sheet or whatever, when they were filing their quarterly reports with their financial people or the SEC, they used to have a line that says, "This is how much money we attribute to our innovation." Then they brought in somebody as a CEO who came from the manufacturing sphere and not the innovation sphere, and they brought in something called Six Sigma. I'm not saying Six Sigma is bad. Six Sigma is good if you're doing manufacturing, because Six Sigma is all about reducing defects and reducing variability. But when you apply it to everything in your organization, you start to reduce innovation. The innovation at 3M, by the way, was the Post-it notes was there's a scientist who was looking for a super glue. And he created a compound as a super glue, but it wasn't super at all. In fact, it only barely held anything. And so what they used to do around the office is they would put the super glue on the back of paper and stick it up on filing cabinets in the wall and whatnot. And that's how the Post-it note was formed, right? That's innovation. That's thinking differently. So after this Six Sigma guy, CEO, came in, it wasn't long before they stopped reporting at all on innovation because they stopped being innovative. You cannot do that in product development. You cannot do that in software development. It will kill you. What is the variability in the G-Goat greatest graphic of all time? It's these different dollar signs. We tend to put everything in a project. We split up this thing that has value into smaller pieces. Usually, I just remember from old days, it was called WBS, work breakdown structure. We break it into different work pieces. Each one of those pieces, though, like items in our backlog, will have a variability in terms of their value and effort, right? We should not consider the project or the accounting code when doing the development of the product stuff. We should consider the dollars and cents, the economics of it. We should do the highest value to effort items first, regardless of which project they're from. But that's not the way project management works, especially in waterfall. Let's talk a little bit about variability here. You can add variability in product development without adding value. This is easy enough. People understand this. I worked with an Agile coach one time. He says, my job as an Agile coach is to disrupt the organization. I said, oh, slow down there, fella. No organization wants to be disrupted for the sake of disruption. The only reason you want to disrupt an organization is because you're going to disrupt it so that you can build something better. You just don't break things and assume that you're going to build things up better. That's not a good way to go about your business. You can do that. I can add all kinds of variability into my processes and my procedures and the things that I do, but I might not add any value by doing so. We usually call that chaos. Agile is not about chaos, by the way. I used to have a product owner who we would spend the 2-week cycle refining the work that was at the top of the backlog. And then the day before sprint planning, she would come in and she'd bring in 10 new items and say, you need to work on these items. I said, we can't do that. She said, why? I said, because we haven't refined them. We don't know the work. We're not going to be able to do the work very well for you. The quality will suffer. We need to spend a little bit of time understanding it. She said, but we're agile. We can do anything. That's not the definition of agility. Agile is not chaos. All right, so you can add variability without adding any value, but the converse is also true, I believe is the word, the converse. You cannot add value without adding variability. And this is the problem I have with PMOs, project management organizations. And this is the problem I have with most, I would say most of management, not leadership, most of management in the complex world. Is what management does is management tries to always, because they've been taught this since like they were, day one, to reduce variability. We should all do the very exact same thing. And wrong answer. If we all do the very same thing, how do we know if we're doing the right thing, especially in the complex world? The only way we're going to know is we're going to try different things and we're going to see how they work. You want to court variability in the complex world. You don't want to squash it, but that's what PMOs do. And it is the very first thing that they'll do before they do anything else. It's amazing that some of the agile transformations I've been part of, where I haven't been leading them, but I've been kind of, a part of them, have been done in the worst waterfall way. I just throw that out there. Reinertsen uses stock options as an example. And he uses the term, and I love this term, asymmetric payoff. That's what you're looking for. An asymmetric payoff are the things that are things that you pay a little bit of money, but you have a huge upside. This is something that Nassim Taleb calls in his book Anti-Fragile. He says we got to make small bets with large upside. We make a bunch of small bets because one of them is going to pay off. This is what venture capital companies do, and works pretty well for them. These asymmetric payoffs are what we're trying to find, and you only find asymmetric payoffs when you have variability. Variable value versus variable effort in most cases. I did a lot of independent study on probability at a great cost to myself, so I could bring you these lessons. Have you ever been down to a horse track and you have 10 horses who have the same average speed? You will, if you're a smart investor, choose the horse that has the highest standard deviation, not the least, because that is the horse that at one time might actually run faster than the others, right? The deviation, the variability is a value in this. The variability is a value in stock options. Stock options is a perfect asymmetric payoff because it's heads I win, tails I don't lose, right? Because in stock options, they say, here's your price to buy the stock. And that's fixed. So if the stock is above that price, of course I'm going to buy it because I immediately made money. If it's below the price, I just don't buy it, right? Heads I win, tails I don't lose. I love that. Asymmetric payoffs. That's what we should be looking for in product development. What are the things that we can do with very little expense and effort that are going to produce the most impact? We only do that when we court variability, when we manage variability, when we lead with variability. How do we exploit it in Agile? Same things I've been saying the whole day. We understand variability is a given in the complex world, in the knowledge-based world, and we take those things that we could do to enhance our product. And I told you the story how everything to me is an enhancement, right? Because once we write one line of code, everything we do is enhancing that line of code, whether we remove a defect, whether we add a feature, or whether we pay down some technical debt. Because it's a product, it's not a project. This is the problem with project mentality, by the way, because projects just tend to be enhancements. And we do those enhancements, but we do so at the expense of the product. This is product management, not project management. They're not the same thing. Each product backlog item is given some kind of relative estimation of what will it do for me as far as return and what is it going to cost for me to get that return. We call those things value and effort, and then we sequence it, right? Going back to day 2. That's why day 2 is so important, because everything we do in order to create and make money, because I'm cool with making money. Everything we do to make more money, to be optimal, right, is ensuring that we're doing the highest value things that have the least amount of effort. Here's another thing that's really important. When I talked about this variability and the problem that I have with the PMO organizations in general, is PMOs tend to have a big, thick book somewhere. Now it's not a book anymore. It's a wiki probably, right? It's a SharePoint site. It's a Word doc. And in that Word doc, they have all the rules. And they call it governance. Governance are the rules that we all have to live by. If we create rules for everybody, what have we done to innovation? What have we done to variability? We've squashed it. What I've done instead, and what's been most successful, and I don't get this opportunity very often, but I once had an opportunity to do so. I created a document that didn't say governance. It said governance and guidance. Governance being those things that we all need to do in order to be safe. Not safe like scaling Agile framework, but safe as in psychological, physical safety. What are the things we need to do in order to be safe? And then there was very little of that. I wanted to make that as small as I possibly could, right? And then there was guidance. What was guidance? These are the things that good teams do. These are the things you should consider doing. What were those things? BDD, TDD, pair programming, mob programming, blah, blah, blah. CI/CD. These are the things that good teams do to be agile. Are we going to mandate you do them? We're not going to mandate you do them because we don't know. Plus, maybe you'll come up with the next thing that's TDD, mob programming. We have our good friend Llewellyn Falco who's talked to job hackers twice. He lives out here in San Mateo. He was one of the founders of mob programming. When did that happen? I don't know, 5, 6, 7 years ago. Maybe somebody on your team's going to find the next thing, right? But if we tell them you have to do this, are they going to find the next thing? Nope. Just following orders. Didn't work so well. World War II, right? So we shouldn't have a lot of governance. What things keep us safe in governance? Well, it's usually mundane stuff. And this is the stuff that most coaches want to go. A lot of the stuff that I found that we had to do around governance had to be around how we use tools. Because we all had to use them in certain ways so that leadership could see certain things and not have to try to reinterpret numbers, right? So you're creating a dashboard. You might have to have certain amounts of data that you need to collect so that you can have certain things show up on the dashboard. We had to govern that. We had to have rules around that so that we could all work together, right? The analogy I use, which is almost perfect analogy, is what side of the road do you drive on? Well, it depends on what country you're in. Is there one side of the road that is objectively better than another? My answer is no. Somebody will probably come back and tell me I'm wrong with that, but I don't think there's any difference between driving on the right side or the left side, because I've driven on both sides and it seems about the same to me. The key is not which side do we drive on, it's that we all drive on the same side. Why? In order to be safe. I did take a trip to Hyderabad, India, and I didn't know what side of the road they drove on, but they seemed to figure it out. So that's a different story. But very little governance, things that we need to be safe, lots of guidance, lots of leadership saying, here's what good teams do. This is what you should aspire to. This is what you should be working to. We encourage in the sprint retrospective, and not just in the retrospective, but throughout the organization, what we might want to call safe to fail experiments, right? When we were talking about retrospective, we talked about retrospective in the sense of that what you're trying to get to is not just some kind of fancy bitch session, but what you're trying to get to is you're trying to get to actions, things that you're doing different. What are things that you do different? That's variability. What variability are you going to introduce into your system and test to see if that variability is actually valuable, right? Safe to fail experiments. I have a hypothesis. I believe that if we do X, we will do a better job. Okay, how do we experiment with X? How do we control that experimentation so that it's not chaos? Because we don't want chaos, right? You can add variability without adding value, but you can't add value without adding variability. So what variability can we add into the system and then measure the effects? And if it's good, we'll continue to do it while it continues to be good. And we do that usually through the retrospective, but we can do it at any time, right? You can do it any time, but retrospective is a good time. And we always have that time. That's the beauty of this cadence. We talked about that on day 3, right? Having a cadence. Because we know that every 2 weeks, if we have a 2-week sprint, that we're going to have some time where we're together to talk about experiments. Great. But that doesn't mean you have to talk about them during the retrospective. You talk about it anytime. If you have to set up a special meeting, set up a special meeting. I don't care. But that's why we have those cadence, because it's like the bus. It comes around every 10 minutes. You don't have to worry. You missed one, you'll get the next one. This is the beauty of cadence. Okay. Gosh, I don't get at all enthusiastic about this topic, dude.